Question 13, it's on modulus graphs. We've got to sketch that. So let's sketch y equals 2x minus 3, ignoring the modulus, and then we will reflect anything negative, any negative y values in the x-axis. So this graph is going to have a y-intercept of minus 3 and a gradient of plus 2. So it's going to go up like this and carry on going up. But then we want to reflect all of this in the x-axis, so it's going to go up like that. I do use a ruler. I can't work out how to use the ruler. Actually, I can do this, but I can't spin it around, which is quite annoying. So let's forget it. But do use a ruler yourselves. And this is going to be plus 3. This will be 3 over 2 because you just put y equals 0 and solve it. And that's it, really. You won't just want to get rid of that. And that's the answer. So the next bit, given that the graphs of, well, the one we've just drawn and ax plus 2 have two distinct points of intersection, what could A be? All right, let's do this on this graph I've got down here somewhere. Where is it? There's one, there's another one, okay. All right, let's just make this a bit bigger then. Okay, so the graph of, it's talking about the graph of y equals ax plus 2. Now that is definitely going to go through 2 there, and a could be anything, so we don't know what the gradient is, but we do know there's 2 points of intersection. Okay, so let's say that we know the gradient of this is so the gradient of this is 2. So let's say the gradient of this graph is also 2. In other words, let's say that a is 2. We would get a graph that looks parallel. Oh, that's not very good. We'll get a graph that's parallel to this one. Okay, oh, still rubbish. All right, that'll do. So that will only have one point of intersection, only one point of intersection, and that point will be here. Okay, so that's no good. So we need the gradient to be less. So we need the gradient must be lower than 2 in that case. So then there will be 2 points of intersection, like that would be, okay. But also we can't go too low, otherwise the line would go below. Let's do this in black. So if it's 2, if the gradient is too low, negative, it will go below that point there. Okay, so let's say the graph looks like this. So that'd be y equals, and then we don't know the gradient of this, but we can work it out, can't we? Because we know this is 2 because it's the graph of something x plus 2, and we know this point here is 3 over 2. So this gradient here, the gradient of the black line, is going to be 2 over 3 over 2, which is 4 over 3. So that black line is going to be 4 over 3x plus 2. Okay, so the gradient of the line that it's talking about, ax plus 2, that value of a must be between this value, sorry, that's negative, isn't it? So this is negative. So this would also, so this also only has, what is it doing? Only one point of intersection, which is here, of intersection. So therefore, this graph here, in order for it to meet the red graph at 2 points, it needs to have a gradient between this and this. Okay, so let's just write that down. So there will be 2 points of intersection, 2 points of intersection when A is between those two values, so -4/3 and +2. Alright, now on to B part 2. Okay, so again, it's talking about the line y equals ax plus 2, and it says there must be 2 points of intersection. It's saying what would the points of intersection be? What would these x values be in terms of A? Well, let's just take this this section over here. Now that the gradient of that line would be -2. So the grade this line over, let's do this line first because it's easiest. This line is just y equals 2x minus 3 because we didn't need to reflect that at all when we drew it. It just stayed as it is. Whereas this one, we did reflect in the x-axis. So this is minus 2x minus 3. So this line is y equals minus 2x plus 3. All right, so what are those 2 points of intersection? Well, this point of intersection here is given by solving this equal to this. So we've got minus 2x plus 3 equals ax plus 2. So 1 equals ax plus 2x. Factorize, and we've got x, a plus 2. And so x is 1 over a plus 2. That's what that x value there is. Let's do the other one over here. So this point of intersection is when 2x minus 3 equals ax plus 2. And so 2x minus ax is going to equal 5. And again, we can factorize and divide by the bracket. So x is 5 over 2 minus a. And that corresponds with that x value there.